Namaste students. Myself Professor Vijay D. Chaudhari, Assistant Professor and MTech VLS Embedded System Coordinator, Department of ENTC Engineering, Godavari Foundations, Godavari College of Engineering and Polytechnic, Jalgaon. In today's session, we'll see an insight on embedded system development and its application. The contents which we are going through are initially the definition of embedded system, embedded computing system, various categories of embedded system environment, application area and its market, recent trends in embedded system, key factors of embedded system and embedded real-time systems, which are the processor technologies supports the embedded system development. We also compare with embedded system versus general purpose computing, and then we will conclude. So, various experts have defined the embedded system as per their expertise and experience. Vinewolf has defined that embedded system is a device that includes a programmable computer but not itself intended to be a general purpose computer. Galvano mentions that a microcomputer with mechanical, electrical, chemical devices attached to it, program them for some specific and dedicated purpose and package as a complete system, which is called as an embedded system. The Indian expert Raj Kamal has defined in a very simple way that embedded system is a hardware with software embedded in it, and that software is the most important component in that embedded system. So in a nutshell, embedded system is what? Computers inside a product. Embedded computing system, various examples we used to see around us in our household or in automobile. Various functions are there which are designed for the ease of using of the public, and various units are there. Those are produced yearly in comparison with the desktop unit. So nearly any computing system other than the desktop computer, it is called as a embedded computing system. So what are the categories of embedded system? Three categories: computation oriented, control oriented and hybrid. Means computation plus control. Computation oriented example, we can see MP3 player, MPEG decoder. In control oriented, home appliances, industrial controller, safety critical controller, and in hybrid, say portable information devices, for example, cellular phone. Network multimedia applications are also included in the hybrid embedded system. So the applications of the embedded systems we can see here in pictorial format. Most of you can guess what are the devices are those that you can call as a embedded system. So embedded system in home environment, embedded system in work environment, means number of the electronic devices are connected using network with the common server. The navigation system, portable music player, communication, automotive, space, consumer electronics, medical electronics, computer electronics. Similarly, many devices are there, many applications are there. Okay, those are incorporating embedded processor, which contains a specific code to get the work done from that device. And you can see here many devices are there: autofocus cameras, automatic tailor machine, automatic toll system, cell phone base stations, cordless phones, cruise control, disk drivers, electronic card readers, home security system, life security system, portable video games, network cards, TV, VCR, DVD player, video phones likewise. So these are the various fields of embedded systems application: automotive, is automation, consumer electronics, medical electronics, remote automation, industrial control, automotive electronics, military, aerospace, telecom, and datacom. So the market scope for the embedded devices are increasing much these days. Various embedded processors are useful for the various devices in this market scope. So to have a quick look for those embedded processors, let us say automotive, medical, ARM Core Fire 8051 AVR MSP 430, consumer electronics, office automation, ARM Power QUICC 8051 Da Vinci, and the most popular embedded processor from Freescale Semiconductor is used in industrial control like robotics, control system, various cars, satellite, nuclear reactors, space stations, shuttles, etc. Most probably, Power QUICC is used in networking, router hub, gateways. Let us see some trends in embedded system. What is the basic that enables embedded system to grow these days much? The Moore's law is the basic, of course, which is predicted in 1965 by Intel co-founder Jordan Moore. What he said? He said IC transistor capacity has doubled roughly every 18 months for the past several decades. So what happens if the IC transistor capacity increases? If the IC transistor capacity increases, the functionality that is to be performed by using some particular embedded system has also increases. The performance increases, speed increases, and also the number of tasks to get done by that embedded devices also increases. So the world of ICs are shrinking day by day. The size is shrinking day by day. More and more functionalities you can add in that. Okay, so the most recent, you can say, the applications which are more advancement due to this research of the Moore's law. Let us see some trends. For example, wearable health monitoring, AMON, a wearable health, multi-parameter medical monitoring and alert system. It has two parts: online medical mission control (MMC), wrist monitoring device. Wrist monitoring device looks like this, AMON. It has various medical sensors: pulse, blood oxygen saturation, blood pressure, one-lead ECG, heart rhythm, skin temperature, etc., etc. Some are optional. For example, glucose level, respiratory flow, like this. So both these two devices are connected with each other through GSM. What the sensors used in this wrist monitoring devices are very sensible. Their clarity, their quality is much higher, sensitivity is much higher. It can sense the just beat changes in the human body, you can say, and just send that data to the MMC. In MMC unit, there are some standard parameters with which all the parameters are getting compared, and if those are somewhat above or below the required one, then immediately the patient has been alerted, or the human being has been alerted, and suggest for the medical treatment. Lifeguard. Similar system is lifeguard, a multi-parameter variable physiologic monitoring system for space and terrestrial applications. The heart of this one is data logger, which collects all the data, all the required uh, input from the sensor, and then take the decision to what to provide to the space shuttle. Okay, what the data okay, need to be controlled. See here, while designing embedded system, first its prototype will get checked. Okay, first the prototype will get tested whether it is working properly or not. If it is working properly, it is validated and confirmed that yes, that device is now quality product that we can now produce produce in a bulk and sell into the market. Okay. So this is the one of the setup. For example, this is a prototype of blood pressure monitor. You can see here microcontroller unit PIC16877. Okay, with max 232 communication media. Signal conditioning circuit is there so that whatever the signal sensed by the sensor, okay, if it is weak, then it is the noise is removed. After removing noise, the signal will get amplified again and then provided to the microcontroller for further process. Okay, blood pressure cuff and pressure sensor is also there. So similarly, smart car control is also there. You can see here infotainment, telematics, vehicle bus communication, body electronics, powertrain and engine management, instrument cluster. Means various small areas are there where embedded devices are used to completely make this car as a smart car. Similarly, digital camera is also a renowned embedded device where microcontroller keep track of each and every action happening while clicking your pic. Means clicking the pic, getting the image, processing that image, adjusting the pixels, uh, show transfer it to the uh, either laptop or the PC for saving or just display it on the LCD display of the camera. Okay, then zoom in, zoom out, what those operations are there to make the clear image, adjusting the background of that image, background light also get adjusted. All the activities are uh, getting tracked by the microcontroller. Of course, the microcontrollers are well programmed by the embedded engineers in such way that the device can able to perform the operation okay, continuously until and unless the power supply is on. Similarly, smart home monitor is there. This is the actually dense network of the sensor and the monitor nodes. Okay. It has balcony, living room, bathroom, bedroom, whatever the security issues we can able to implement in our home, whatever the environmental monitoring and control options are applied, which objects are placed where. If you want to tag that object, then object tagging application can also be implemented, and object identification is also implemented using the embedded system. And in a nutshell, you can make your home a smart home. Okay. Similarly, military, health, agri, and vehicular monitoring all are using wireless sensor networks to monitor the situation at that particular place. Okay, you can see here three key functions are there in the wireless sensor network: sensing, processing, and communicating. Okay, why sensor networks are why means what are the advantages of these wireless sensor networks? These are small devices, low power, consume low cost, uh, uh, small devices, low power, low cost, limited computational and wireless communication. Okay. These are the advantages of using WSN. Similarly, another sentence is in wireless application. For example, how your information is processed in distributed way or centralized way. So accordingly, trends in information and communication has very much important these days. Centralized system, network system, large scale distributed system, new applications and system paradigm. Let us see the key factors of the embedded system. First one, your embedded system should be dedicated one. Means it can execute the function specified by you continuously until and unless the power supply is on. It is a single function in a way that one program or the task is executed repeatedly for some specific purpose. Okay, example, changing the mobile phone from conversation mode to video mode or camera mode. But it is rather a conflicting requirement because there are some audio and the video portions of the multimedia system which need some multi-rate behavior. So to control such operations, embedded system is needed. Then response time constraint for the various tasks is also there. Okay, if you want to execute some task in some particular period, then your system should respond to the task execution within some specific time. Okay, reactive and real time are the most important properties of the embedded system. Okay, means reactive means whatever the changes happening in surround, your embedded system should be able to adapt it and make the changes as per it and produce the result without delay. For example, life-saving system in automotive, then tightly constrained with fast and low cost, low power consumption, small size and weight are the basic requirements of the embedded system. Either it is an independent system or some part of the larger system. Software which is usually embedded into the ROM, that's why there is no need of secondary memories in embedded system. Now note that real-time system, it is a quantitative system. Logical system means virtual system, it is a qualitative system with respect to time. Key factors of real-time embedded system. So what is the difference between embedded system and embedded real-time system? The critical time constraint is the only difference. Okay. Here in real-time embedded system, task deadlines are specified, the delay are clearly mentioned, the duration required to execute the continuous task is specified clearly. One embedded system should complete the task within the specified deadline only. So the real-time embedded system is a task critical constraint, time critical constraint. Okay, new correctness criteria is there, embedded safety criticality means our system should operate for long hours without any damage, means system reliability. Concurrency means several independent events must be responded by the embedded system. It is called as a concurrency. Distributed and feedback structure means when the process is sensing the data locally and take the corrective actions over it as and when needed. So this means your system is giving particular feedback to the distributed system. Task criticality, how the critical the tasks are, okay, so that the result will be produced within a time. Custom hardware, specifically design hardware, means cell, phone, processor. Reactive computer should respond to the environmental changes and accordingly produce the result. Stability means the deadline should be met after execution of the critical task. Exception handling, it is somewhat like about the interrupt handling, but here is what failure detection and the management is properly done in real-time system without disturbing the current operation. Now, what are the embedded processor supports? This embedded system development, general purpose, special purpose, or single purpose, and application tailored. General purpose, these are the programmable devices used in variety of the application, also known as a microprocessor, for example, Pentium. Okay, these are having controller, data path, program memory, and data memory. Program memory is the actually basic part or basic feature of the general purpose processor. The benefit of this is what? Low time to market and NRE cost. Now, what are the time to markets and NRE cost? These are all the design metrics of the embedded system. Okay. Means once you have decided to develop such product which is useful to the society, and after that idea comes into your mind, the time required to finally produce that device and uh, send them to the customers for sale, it is called as a time to market. Okay, it has high flexibility, means easily if once you change the, you just need to change the software or the package or the app and then use it blindly. Intel Pentium, the most well known, but there are hundreds of the others also. Okay, but the Intel Pentium is famous. These are the general purpose processor. Single purpose means there is no program memory. The programming is already done in the company itself. Okay, digital circuit designed to execute exactly one program at a time. For example, coprocessor, accelerator, peripheral. Okay, these contain only the component needed to execute a single program only. Okay, there is no program memory. Benefit is what? Fast, low power, and small size. Application tailored means application oriented. Okay, means user can able to program now this processor as per his requirement. Okay, means programmable processor is optimized for a particular class of application. This is actually a compromise between the general purpose and the single purpose processor. Okay, the feature is it is a program memory. It has program memory, optimized data path, special function unit. Okay, benefit is what? Somewhat of flexibility is there as compared to the general purpose computing. Good performance is there. Size and power is also in optimized manner. So these are the embedded processors which are suitable for embedded system development. Comparing this, we can see here various criteria are there for embedded system: cost, power, energy consumption, predictability, meeting time bounds, reliability, availability, software core size, security, and in general purpose computing, just the cost, average speed, and the power is mainly checked or optimized. Also, general purpose computing system are faster as compared to the embedded system. But fixed runtime requirement is there in embedded system. Additional computing power is not required. Embedded systems are not easily programmable by the end user. General purpose computing systems are programmable by the end user. Means if you want to perform your program or write your code in say MATLAB, just install the MATLAB. If you want to write your code in VHDL, just install the VHDL. Just install the Xilinx IDE. Okay. So various broad class of applications are there in general purpose computing. There are few applications are there available in embedded system during design time. So finally concluding, what we have seen the various definitions of the embedded system by various experts. Either it is the computer, embedded system is a computer hardware with software embedded in it, Okay, as is one of the most important components. It is a single function in the way that it executes one program repeatedly for a specific purpose. Embedded system is tightly constrained with fast, low cost, low power consumption, small size and weight. Embedded systems should be reactive and real time. There are three main processor technologies: general purpose, single purpose, and application tailor. General purpose computing system is somewhat different than the embedded system in terms of cost, average speed, and power. Critical timing constraint is the key factor in real-time embedded systems. In next session, we will see various design metrics of the embedded system, design approach of the embedded system, and how the software and hardware co-design approach is takes place during embedded system design by the embedded system engineer. Thank you.